6.2, motion. We're going to go specifically into how to calculate and what is speed and velocity. So first off, let's talk about some vocabulary here with the first few slides. Speed is the distance an object travels over time. So distance over time it takes to travel. Some units, because you need to make sure you know your units of things, are going to be things like meters over seconds is going to be the one we use the most, or it could be kilometers over hours. What you're used to is miles over per hour, but most likely we won't really use that too much in here because remember we're doing the metric system. Okay, so distance over time. Now, a lot of times people use speed and velocity as if they're the same thing, but they're really not, okay? So velocity, yes, is speed, but it brings in direction. So it not only tells you how fast the object is moving, it's telling you which direction you're going. So for instance, I'm going 5 meters per second north. Okay, so this is velocity because I give you the how fast it's going and the direction it's going. Speed does not depend on direction. So if you ever get a question asking for any kind of direction piece, it's going to be dealing with velocity. But a lot of times even we will, or even I will ask you questions that'll say speed and velocity kind of intertwined together. Just know that that's the difference between the two. Okay, now we need to talk about different kinds of speeds and velocities. So we got some other words going on here. So constant speed. What does the word constant mean? Okay, we use this word a lot. This just means that the object does not speed up or slow down. So you are constantly going at whatever rate it is. So 5 meters per second. I'm still going 5 meters per second 5 seconds later. Constant speed. Changing speed obviously should mean that it's either going up or down. Another word for this is acceleration. Acceleration means faster or slower. Okay, acceleration is either one of them, and we're going to talk more about that one later on in this unit. Okay. Then instantaneous speed. Instantaneous speed. This means you know for that exact moment how fast you are going. So you have to have some sort of speedometer or something telling you, a radar of some kind telling you what your speed is at that exact moment. Okay, so you have to have some kind of measuring device to go with it. Average speed. Okay, average speed is what we're mainly going to be dealing with in here because you have to do some math with this. So average speed is simply going to, that if you go back to the first slide, the definition of speed is the distance traveled over the amount of time. So what's going to happen here is your formula is exactly the same as its definition. Speed is distance over time. Now I'm going to rewrite this so it looks a little bit less wordy. Okay, so you need to know speed is distance over time, and then you can rewrite it even easier. V equals D over T. Okay, so this has all the units that go with it. This is with the words. This is what's given to you on the formula sheet. Okay, but it's going to be important that you know your units of everything and what the letters stand for. Okay, so I would write all of this down. Now, one thing missing here that's going to help you through the math is the triangle. So let's go ahead and figure out how to draw this triangle. Remember, the triangle is pretty much set up like this every single time. You have to figure out what letter goes where. You look at what you got going on here. D is already on top of a line. That means D already goes on top of the line. The V and T fall to the bottom. Okay, so when we go to do our examples, this is going to be our triangle every single time. Okay, so let's jump to some examples. Do some real quick here. I'm going to go ahead and write the formula for you here. And let's look at what we got going on. Label, and then triangle, and then work it out. So After driving for exactly 60 seconds. This is why it's going to be important to know your units for things, okay? So speed is typically going to be meters over seconds, so you got like a double thing going on. Distance will be meters, time will be in some sort of seconds, hours, or something like that, okay? So 60 seconds. We are going to label that as T. You have driven 600 meters. Meters is a unit of distance. Extremely important to know your units. And it's asking, find what it's asking for. It says speed. So you're looking for V. All right, so we do our little triangle here. Remember, the triangle is going to look the same every single time. We're looking for V, so you get V equals D over T. And all you got to do is plug it in. So you get 600 divided by 60. So 600 divided by 60 is 10. And then the units, when you're looking for speed, all you're going to do is combine them. So meters per second. And that is it. Okay? So let's try another one. Switch colors here for you. After driving for 5,000 seconds. Seconds is a unit of time, so we're going to label that as T. At a speed of 15 meters per second. So you see how it has M and S? That should tell you that that's your V. And it's asking how far. So out of your variables, if I ask how far, what is that looking for? You're looking for D. Okay, so now we're going to use our lovely triangle here. D's on top, V and T at the bottom. Again, every single time it's going to be that because D is on top of the line, so it goes on top of the line in the triangle. This time we're looking for D, so you shade in D, and then whatever is left is what goes into your formula. So how V and T are next to each other here, that means they're going to be next to each other in our formula. So V times T. So all you're going to do is 15 times 5,000. So 15 times 5,000, and you get 75,000. Now, you can do the same thing with your units to figure out what unit goes here, or you see that you have seconds and seconds. They kind of cancel each other out, and you're left with meters. Also, you know that you're looking for distance, so your units are going to be meters. And there you go. Last one. So let's roll through this one quick. You can pause the video if you want and try it on your own and come back. Okay. How long did it take? So if I ask how long did it take, that means you're looking for time. Let me switch colors here for you. You're looking for time. How long did it take? 250 meters is a distance, and it's asking for, or is saying speed of 5 meters per second. So that is your V. Okay, so we do our triangle. Remember, D's on top, V and T fall to the bottom. We're looking for T this time. So you shade in T, and then all you do is you have D over V. Remember, if it's something on this top line, whatever's on top stays on top, and then V goes to the bottom. So now all you have to do is plug in. Do not make the math harder than what it is. Just plug it straight into this lovely triangle. So 250 divided by 5. So 250 divided by 5, and you get 50. And you're looking for time, so you should see that that's going to be seconds. Done. That is it. Okay, now one last thing we got to talk about, and then we are done with this stuff here. Graphing. You're gonna have a lot of graphs. You got to be able to figure out what's going on. So let's talk about this graph going on. When looking at speed, you're going to look at what's called a distance versus time graph. All this means is you have time on the x-axis, and the y-axis is either going to say position or it's going to say distance. Okay, you are going to have to make sure that you always look at that x and the y-axis, or you're going to get your answers wrong depending on what kind of question they're asking you. Okay, so we're looking at time and distance or position graph. Now, if you have a distance versus time graph, the slope equals speed. Okay, you need to write that. Slope equals the speed. So remember, slope is the rise over run. You've learned this in math class. Rise over run. So when you go to find this slope, this equals the speed of your object. Now, if it is a straight line, this means it is a constant speed. So straight line means constant. Constant speed. If it is a curved line, so like this, if that slope is changing, slope changes. If the slope changes, that means you have acceleration happening. Any kind of curve means there's a changing speed. Slope is changing, so you have acceleration. So it's either speeding up or slowing down depending on what's happening to that slope. Okay, in this instance, that slope is getting steeper and steeper, so it's speeding up. Now, that leads us into what we have to do next. I'll just give you a graph, and you gotta tell me what's going on. And you should be able to do that simply by looking at what's happening to the slopes. Okay, so let's look. You need to draw these. First off, draw all the graphs that I'm giving you here. So let's look at this one first. Again, it's going to be distance versus time. We have a straight line. Straight line. Nothing else is happening. Straight line going up. So what you need to make sure that you know is that constant speed. Again, why do we know it has constant speed? Because it's a straight line, that slope is the same. The next thing you need to know is if you look at this graph versus this graph. They both have straight lines, but one object is doing something a little bit different depending on which graph you're looking at. So let's talk about that. This one, the distance is increasing. That means this object is moving forward. Moving forward. This one, you're going from, let's say, 10 meters to 2 meters. This means, again, you have a constant speed, but since it's going backward, or I just told you, since it's going down in the distance, that means it's going backwards. Okay, that is the difference between those two graphs. So now let's talk about these two. We got a curve going on here. Curve. That means as you're going here, the slope is getting steeper. So you should see you draw the slope here versus the slope there. That slope is getting steeper. Steeper slope. What that also tells you is that there is acceleration. Oh, I can't spell today. Sorry. Acceleration going on, okay? And just like these, since it's going up, it is moving forward. Okay, next, let's talk about this one. All right, we got this line, it's curving. Look at that slope that's happening. It's not getting steeper. Eventually, it looks like it's about to flatline here. Okay, and we'll talk about what the flat line means in just a second. It's starting to flatline. That means you have a slope decreases. That means that it's still accelerating, but it's slowing down. Now, it's also, the distance is decreasing, therefore it's moving backwards. Okay? One more graph to talk about, and that's this little flat line here. Okay? Draw this graph. Draw it. This probably is one of the most important graphs because they like to see if you know what's going on with this. So you got a straight line. So if you look at this y-axis, that means it's moving along the x-axis. Time is going by, but since the y-axis is staying horizontal, that means whatever's on the y-axis is not changing. So distance stays constant. So if your distance is staying constant, what does that mean? Not moving. Not moving. The object is not moving at all. That's why it's flatline. So think about a heart rate machine. Once that flatline happens, you're done. Okay, same thing here. The object is not moving at all. It is at rest. Okay, so what I would suggest is to pause the video and see if you can see what's happening with the different ones. Okay, now so let's go through them real quick. What you have to do here for me is tell me which line segment is doing what. So first one, not moving. So looking at this graph given here, which of these line segments is not moving? Your answer should be 2. Why? Because it's flatlined. It's sitting at that 20 meters. It's not moving, okay? Moving backwards at a constant speed. So how do you know if something's moving backwards? It's going to go towards the x-axis. You're decreasing distance. So your answer is going to be 4. Moving forwards at a constant speed. Okay, now both 1 and 3 are moving forward because they're going up, right? How do you know about the constant speed thing? It's because you have a straight line. So your answer there should be 1. And then the only line that's accelerating is going to be one that has a curve. So your answer is 3.